All right. So with this one, we're looking for the length of segment HG. But HG is a tangent segment. It's part of a tangent line. But there's two tangent segments that come from point H. So what from our last page do I automatically know about those two segments? And you can see it by looks what they are. They're congruent to each other. So that means all you have to do, because HG is equal to HK, is 4 plus 2A is equal to 5A minus 32. So you subtract 2A from both. So that's 3A minus 32. Add, right, 32 to both sides, so I get 36 is equal to 3A. Divide by 3. A is equal to 12. But I'm looking for the length of segment HG, because if I ask myself where do I want to go, I need to find a segment. I found, how did I do that? I found a variable that I can substitute back in. So plug it in, plug it in. I haven't sang that for so long. I hope you don't mind. All right, let's plug it in. So we got 4 plus 2 times 12. So 4 plus 24 equals 28. So that's your length of segment HG. Now, quick, we got to remember how some of this stuff is doing here, okay? We want to use the correct terminology. Now, in the diagram below, a circle is inscribed. That means where? Inside. A polygon. If that polygon intersects, if that circle intersects every side of the polygon at one point, notice you have 3 points of tangencies for a circle. You'd have 4 points of tangencies for a quadrilateral. So the circle is inscribed. The polygon is circumscribing. Exactly. So make sure they switch each other. And then it goes the other way around. A circle that contains all the vertices of a polygon is circumscribed. So this just changes how it's done. And the way I remembered how this worked, if I'm circumscribed, I'm circling around it, or I'm on the outside. So circumscribed means this time it's on the outside. So what does that mean for this one? The polygon is where? Inside, so it is inscribed. So this is some good vocab you have to know, but it keeps things pretty straight for us. So let's do quick, let's see if we understand our vocab moments. It says, tell whether each polygon is inscribed or circumscribed about the circle. So I'm describing which one. The polygon, is it inscribed or circumscribed? Circumscribed, outside, inscribed, inside. So the polygon in this one is inside or outside? Outside. So it's circling around, right? So it's circumscribed. Now where's our polygon? Because it's touching each vertex is touching the circle. It is on the interior, so it's inscribed. I loved this stuff. And then what do we do for the outside one? Right, it's going to be circumscribed. All right, hopefully that helps us a little bit on there. Now, I'm not going to stop recording here. I'm going to flip this over, and I'm going to show you this really cool thing that works with the tangent lines and working with inscribed circles. Okay, it says in each diagram, a polygon circumscribes a circle. All right, find the perimeter of each polygon. So looking at this, how in the world am I going to find the perimeter? Because I have to know the length of all of its sides. Like here, I have a missing piece. I know everything but that one little piece. On this other one over here, I have a missing piece here and a missing piece here. Great. How does that help me? Well, let's see if we can break things down into smaller parts. Let's divide and conquer. Okay, right now I still have Les Mis in my head. I'm thinking, you know, the blood of angry men. All right, anyway, I'm thinking like, let's beat them. Let's try to, you know, destroy the troops. Well, let's destroy this problem. You know, I don't know. My brain is going weird places today. All right. So looking at that, do you agree with me? I have a tangent segments coming from the same exterior point. So what's so special about the two of them? They're the same size, so that's 6. Well then, what's the length of that whole segment? It's 9. So what's left here? 3. Well, the cool thing is now do I have the fact that this little one, and let's see if I can highlight the two of them so it's a little bit easier to see. Those two small little segments, okay, they're both tangent segments from the same exterior point. Well, so that meant this one was 3, just like that one was, because they're the same size. Well, but the whole segment here from here to end is 8. Well, what's left for this one? 5. Oh, wait. Those are two exterior tangents from the same point. That means they're congruent. That means that one is 5. Well, now I know the length of that side. It's 11 inches. I can do the perimeter, which is the sum of all the sides. So the perimeter is 11 plus 8 plus 9. What do we get for that? 28 inches. I love it. It's just so much fun for me to see how it works. But you notice I'm marking it up, and I'm going to zoom in here for this one just a little bit, so you can see where I'm going with it. So I go a little bit more. Okay. Now, do you agree with me? These are all little sets of congruent tangents. Well, I'm going to use that to my advantage. So like right here, if this one's 6 from here to here, that one had to be 6. But the whole thing is 10 feet, so that leaves that 4. That leaves this one to be 4. All right, so that helps me figure out this side. That's going to be the whole thing here is 9 feet. But now I need to help solve for this one, so I have to keep using the 5 here. This is 5 feet, this one's 5, which leaves this one to be 7, and this one to be 7. What do we have here? 4 and 4. So this would be 12, that would be 11, and this whole thing, 10. It's all using those congruent tangents. So I got 10 plus 10 plus 9 plus 12 plus 11. Add those together, that's 29 plus 11. That's going to give me 40 plus 12. It's going to be 52. So I'm going to say the perimeter equals 52 feet. Have fun marking those up in your homework. Now, call me if you need to, and we'll see if we can figure this out. But re-looking at your notes, watching these videos again might help you remember how to do these. So have a great day.